Everybody, welcome back to the Copilot Agent series, all about solutions. And today I'm really excited. Aline is going to be talking to us today about deep reasoning and Copilot agents, and it just takes things to a whole other level. So I'm really excited to see what she's going to be showing us and how our customers can actually take advantage of the power of it. So Aline, take it away.
Thank you, Michael. Hi, everybody. It's great to be here. Continuing our series on Copilot agents and in Copilot Studio. And today I'll be talking to you, like presenting a little bit about deep reasoning in Copilot agents, right? So we will talk a little bit about use cases and the different settings that we have in place when these agents are created. And I'll do some demos as well so we can gradually go over how the orchestrator will balance deep reasoning with traditional reasoning. And what's the difference after all? What's involved in deep reasoning versus traditional reasoning in agents? Um, and I will start with our problem statement, actually. So in many situations, we want agents that are able to not only provide answers in our agents, but also show how they came up with that particular answer, right? So in academic, in academy, you want not necessarily come up with an answer, but show every single step that was used to come up with parts of that answer, apply other proof scenarios on top of it, and show all the different also premises and assumptions it used in order to come up with a result, right? So we want to have some agents that emulate that behavior.
I love that because you know what it reminds me of too, because back in high school, going way back, doing geometry, in a geometry class or even algebra class, you'd have to not only provide the answer to the math problem, you had to show your steps, right? Which helped you see, not only is it right or wrong, but where, how did you follow logically to get to that point, especially in geometry, where you're doing theorems and proofs and proving that out. And if there was an error that led to an incorrect answer, being able to see the logic and reasoning and where that was and being able to adjust on it. And I love that with deep reasoning, we're showing that progression so that the professionals, the real subject matter experts, can actually look at the logic that's being applied and the steps taken to arrive at a given answer. That's awesome.
Exactly. And what variables you can change to come up with different answers as well, right? So we want to use a methodology that is based on also extensive data, so able to work with high volumes of information and also show not only the steps to come up with the answer, but also variances on those steps, like multiple ways to come with the same conclusion as well, if that's the case, right? So it will be case by case. And in this case, we'll be leveraging in Copilot Studio the Azure OpenAI o1 series of models that are able to complete that type of reasoning. This is a capability that's currently in preview as of April 2025. Not fully released yet, but already available to customers in target release. So if you are in target release, you can already experience those models, although they are not fully generally available to all customers. Okay, so and when we talk about deep reasoning, before we come into the demo that I have ready to share with you all, I just want also to explain a little bit about the balance between different models, how we use and how the orchestrator in Copilot Studio will decide when to use and what are the implications of using those different models as well, right? So we use deep reasoning when we want to make sure we give full visibility of the thinking process. We've been talking about that, right? So for some particular scenarios, we don't necessarily need to show that type of information. If if a person that's a medical professional, for example, asks a question about, define me what this particular disease means, it goes to a knowledge source that has an explanation, outputs the answer. There's not much thinking. You just like retrieve and display the type of information, right? But we also want to make sure, no matter what type of model we are using, that we're also referencing the sources of that information, how the thought process was output, but also that can be used in order to actually be transparent in terms of the process of coming up with a solution. And in these cases, we also need to balance like accuracy versus speed, right? We want answers fast these days, and are coming up with models that are actually very good at coming with answers in long outputs in a very optimal speed, right? So we get the answer when we need and it's fast.
Right.
But some analysis may take a little bit longer. And it's okay. We might want to provide that type of instruction to our agents to say, hey, reason over that information. Take your time to come up with an answer. Check all possible conclusions that you are able to analyze. So giving that agent extra time to reason might come up with a better quality in the answer. And there's no right or wrong in terms of when to use each one of those, but there are some directives and some instructions we can give to the agent, to use a very familiar term to us who've been developing agents, right? We give the right instructions, we can come up with um, different results. And of course, the last bullet point here asks, like, what's the cost associated with it? Certain uses of certain models come with an associated cost that's extra comparing with what already is available with the general large language model that MT65 Copilot and Copilot Studio use. So balancing the cost of number of messages consumed and how long it takes for it to like come up and process all the information is something to take in consideration when you also structure the governance of those agents on who should have really access to that. Right. So different needs will come up with different responsibilities and different associated governance and costs that need to be considered.
Excellent.
Awesome. So let's then see in practice what I mean. What are some of the possibilities with deep reasoning? I'll share my screen, my lab tenant. Think we should have a good resolution. I'll be reading some of the things that we are displaying here, so you guys don't have to go over every single detail. But if I go back to the overview for this particular agent that I had created here, I named it an outbreak response helper. So the idea for this agent is it'll be an agent that checks following some public information. In this case, I'm pointing to the cdc.gov website, information about diseases, symptoms, transmission, and also what are the measures we can take to avoid an epidemic of a particular disease. Please note that this is very like a demo, now where I'm not trying to be a medical professional. I'm not a medical professional, not providing any type of medical advice here. So this is supposed to be a tool that supports those professionals. What comes with like something very important for us to remember. Copilot and any generative AI tool, they are a tool, right? It's still important to have the human factor involved here. These answers might not be accurate, and we still need to like to trust but validate. And again, we need the pilot to actually make this Copilot work.
Right. Excellent.
Okay. Yeah, so it is a tool that will help us understanding like the cycle of some diseases. We can start with like very simple questions and like progress into some more complex ones. In this Copilot here, I'm also using generative orchestration. So we see that it is Gen AI deciding when and how to respond to the different events. Um, Something also important in this case here, if I go to settings for my agent, I just wanted to show you guys up where we had that like um, Gen AI configuration setting in place and how to actually leverage that premium deep reasoning model.
That's
So if we
new.
need to go to settings, Gen AI, and then we have like a new panel, to your point, that is only showing up in preview for preview customers. I have a dedicated environment created for this particular agent here. And I had the enhanced search results enabled and also my deep reasoning models enabled here as well. So if you already have that in your target release tenant, you can click on learn more. We will have some general information about not only this setting, but also pricing and what's the version of the model. More information. We will also make it available in our page for this video as well. How to learn more about this. But going back to our agents, I'm just gonna close the settings page here. So that's the first step. Go ahead and make that available for us. And this tenant, by the way, this environment that what I had my agent created is using pay-as-you-go configured for this environment, so I can go ahead and test um, this capability. So it requires a little extra configuration, not just your regular M365 Copilot license, but some settings at Power Platform administration level to be configured, right? Okay, so we were talking about how this is pointing to the measles side at CDC, and we can, like I said, with very simple questions. So, what is measles? And it will give us the information. We're going to see that Copilot Studio offers us a way to track down the activity, which knowledge sources, if I had multiple knowledge sources, were used, were consumed, and when it was able to find the information. So it went to the public site, to the CDC Gov slash measles site, and got information about the disease. So that it's a highly contagious viral infection, what are the symptoms, what are the complications, how it gets transmitted, how it can be prevented, what are the highest risk groups. And we have like a reference for each one of those informations, which pages in that website we can find the actual source of information, right? This is just regular agent reasoning, nothing new, no deep reasoning involved. We can also ask questions like, is there an outbreak of measles in progress in the US? And then it should like also, if there is that type of information can be found, it's going to check the knowledge sources and go ahead and get information. So yes, as of April 2020, April 24, 2025, there's a total of 884 confirmed cases of that disease in that particular location. So we can keep asking questions and getting answers. But then now let's imagine we want to get a projection. So we know how many cases we have. There's an outbreak, like 11 outbreaks reported. And what does define an outbreak? We can keep asking that question, those questions. That information is should be in the knowledge source. If it's not, it's going to tell us. But which state has the highest rate of measles, and what's the we can ask about immunity, herd immunity, right? So and herd immunity rate It might give us that information, might not give us that information. We can wait to see if it has that information. So the herd immunity rate for measles is achieved when more than 95% of people in the community are vaccinated. So then it comes to, maybe let's start trying to come up with some deep reason in terms of vaccination rate and herd immunity.
So,
for example, go ahead.
Up until now, then it's been really the classic generative AI. I say classic like it's been around forever, but classic, where we're asking questions that there are answers in the body of text and stuff online. So it's able to retrieve that, synthesize it, and put it out like generative. Now we're moving into more of we're going to start moving into the reasoning pieces, which get to that deeper level.
Yes, that's correct. So
awesome.
I just clicked in the source here, the link, and then it opened up the CDC page that has the type of information that has exactly that information regarding when it was last updated, how many cases, the states where the cases are being found, the number of outbreaks. So it's really almost a copy and paste of that information into the age, and you have the source, you can refer to that. Ask. So it would take for the herd immunity fall below, let's say it was saying 95%, right? So 90% in, I'll say Texas, in if the same region of transmission continues over time. Show reason over this information. It should, because I said there's a very important triggering wording that I used in my prompting here as well. So I explicitly asked to reason over the information, right? So that directly helped the orchestrator know, see that now it is activating the reasoning model. So reason with advanced model. And it says no official data directly has that type of information. And it's important to know that herd immunity depends heavily on vaccination coverage. But then it goes ahead and tries to find information on vaccination coverage that I didn't provide in the website for the school year that it has that information. So it looks like it doesn't have for the current for 2024 or 2025, but it has that type of information for the school years between 2019 and 2020. And then it goes like it's decreased roughly 2.5 percentage points for over 4 school years. It explains the reason to come up with certain answers. So it didn't give me, in this case, a numeric information because it knows it doesn't have enough numeric also information to give that type of information. If we come up then, and I'm gonna stop here with the reasoning because it's much more complex that we can actually cover in this simple demo. But if you have data, the large amount of data that we would need for this type of reasoning, and then over time and ask for calculations to be made, it can come up with the deep and complex equations that would need to be used with in order to come up with the results. So it's a very good model to actually perform a deep calculations. This would be potential a good use case to do this type of extrapolations. Other examples in that space would be like to project contaminations, and also we have different types of calculations related to all sorts of like healthcare and life science situations, lifespan, the health in the community, what are different factors that can help track correlation between certain information and data pools. So we can, if I have like, let's work with some hypothesis. For some sample calculation. Suppose the herd immunity for a certain area is dropping by 2% year over year. Project how long it would take for herd immunity to drop to 85%. So completely theoretical, not giving any type of like real information, but I still can say reason over this calculation. So it again opened up a deep reasoning model. It takes longer, as you can see, comparing to the usual finding and answering the type of information. But now it's showing us a little bit more how it did that, right? So the difference between the starting coverage and the target, the annual drop, time to drop, 10%, 10% at 3% a year. So it would like take approximately 3.33 years to come up with that particular. So it shows in words, it shows the math that you can use to do that. So this is the formula. It's still a very simple formula considering the potential of what this can do. You
I
can
think people
add
can
more
get the
variables.
idea. Yeah, no, this is great.
Yeah, so just to show potential, again, you can apply all the other concepts we've been discussing on the other series to keep improving your agent. Before we wrap up, I just want to show pretty quickly that there are some considerable differences in terms of message consumption for basic interactions versus premium interactions. This is just the utilization rates depending on the type of agent, depending on the license that we're using, the grounding. So we know that the factors we have here to influence types of the cost of interactions are the knowledge sources, the type of orchestration, and the model. So if you're using basic or premium capabilities, I'm not going to go over lots of details on this, but we'll have like links to provide more information at the end. Keep looking as well. We might using generative mode for orchestration versus classic mode have different what, why, and hows for you to apply. I recommend actually also explore further that type of balance between how much generative you want your agent to be, and if you already have like classic topics and actions for predetermined use cases, it'll be part of the designing of your agent.
Cool.
Yes, Mike. So that's all I had to demo today.
It's awesome. I mean, I think it becomes readily apparent to people, especially if you've been doing generative AI. And I thought it was funny because you use the CDC site. So I built and showed how to build agents for the CDC site, right? But they were classic. And so you can see like those pieces like in your initial, really sticking to the classic, but then when you switch into that reasoning, it knows on the back end what to do, and then you start to see the reasoning of what it's done. And really, for a professional looking at it, you can start to evaluate the quality, not only the quality of the answer, but the quality and process of the reasoning. So if you need to switch it up and say, let's change this variable or that, something that it did in its reasoning, there's full transparency, so you're able to do that.
Yes.
It's awesome. It's awesome.
Yeah, my pleasure being here. I hope everybody enjoyed this video and keep studying and keep exploring and creating awesome agents.
Well, thank you very much. And everybody who watched today, have a great day and take care. Bye now.
Bye for now.